Hello, linear algebra students. This is our first extra practice worksheet, and the topics for this worksheet cover some of the material in sections 1.1, 1.2, and 1.3. So our first example, we want to solve a linear system, and let's write down the augmented matrix as our first step. Well, the first column, we see 1, 2, 3. And the second column, we see 1, 3, 5. Then we have -1, 1, 3. 1, 0, -1. And then finally, it's augmented. And so for our last column, we have 1, 4, 7. Well, you notice our first step, I want zeros underneath this first one. And so we can take -2, row 1, add that to row 2, and take -3, row 1, add that to row 3. Let's see. I will just copy and paste this augmented matrix and then make some changes. So note that row 1 has not changed. -2, row 1 plus row 2. We have 0, 1, 3, -2, and 2. And then we have -3, row 1 plus row 3. We have 0, 2, 6, -4, and 4. Well, this looks great. Now, I want to take this one and get a 0 underneath. So I take -2, row 2, add that to row 3. You notice row 1 and row 2 have not changed. And when I take -2, row 2 and add it to row 3, well, you see I get 0 all the way across. So really I only have one more step here. I want to make this a 0, and then this augmented matrix will be in reduced row echelon form. So let's take minus row 2 and add that to row 1. So we have 0, we have -4, we have +3, and then -1. And this is in reduced row echelon form. You see we have 2 leading ones. And so in particular, this column and this column correspond to free variables. So let's see, this is x3. Let's say x3 is t, and let's say x4 is r. These are our free variables. Well, the first line in reduced row echelon form, it says that x1 is -1 is going to be plus. It would be plus 4x3, but x3 is t, so plus 4t, and then -3 x4, which is r. So we have x1, x3, and x4. All we need is x2. And if we look at the second line in our reduced row echelon form, it says x2 is 2. It would be -3 x3, which is t, and then plus 2 x4, which is r. Now let's write this in vector form. We have found all solutions. Note that we have infinitely many solutions, and we have 2 free variables here. So let's write this in vector form. We have x1, x2, x3, and x4. x1 is -1 plus 4t minus 3r. x2 is 2 minus 3t plus 2r. And x3 is t, x4 is r. Now we could write this as a sum of 3 vectors. But it's also fun like this. So I will just leave it this way and I will underline my answer. This is number 1. Now number 2 is related to this. It says, let A be the coefficient matrix of the above linear system. And then I give it to you what A is. Can A be the coefficient matrix of an inconsistent linear system? Well, certainly the system above is not inconsistent, but the question is, can I have some linear system that has this coefficient matrix and have it be inconsistent? Well, the answer is yes, of course, but let's discuss why. That's part of the question. So the answer is yes. And in fact, we've done all the work. So note that the reduced row echelon form of A, well, I can scroll up. The reduced row echelon form of A is here. But more importantly, for this question, this has a row of all zeros. And so you could easily make a linear system that's inconsistent, but has this coefficient matrix. In particular, let me scroll up here. In particular, all I would need to do would be change this last number here. I could make this anything but 7. In particular, if this here or here was a 6, then once I got to this last line, I would have all zeros and then something non-zero. So definitely the answer is yes. Okay, let's move on. This is related to the last question. We have a linear system with 2 equations and 2 unknowns, and we want to find all values of h and k that make this inconsistent. Well, it very much goes along the ideas of what we were just discussing. So let's just write down the augmented matrix. We have 1, 3, we have h5, and then we have 1k. Well, really, I just need one row operation here. To simplify, let's take -3 row 1 and add this to row 2. -3 row 1, add this to row 2. Row 1 has not changed, but maybe I'll fill out row 2 first. Row 2, we have 0, and then we have 5 minus 3h. We have k minus 3. And as I said, row 1 has not changed, okay? Well, to be inconsistent, we need 2 things. We need 5 minus 3h to be 0. And we need also k minus 3 is not equal to 0. Because then here, we will have 0 equals something non-zero. Well, we can just solve. We get 3h is 5. We have h is 5 over 3. And at the same time, we need k to be not equal to 3. So this is our final answer right here. Those are all values of h and k. Number 4, we have matrices A, B, C, D, and E given. And we want to determine which ones are in reduced row echelon form. And then we will also list the rank of each matrix. Okay, well, maybe I will start with the first one that is, and this is letter A. I will highlight the leading ones, leading 1, leading 1, leading 1. Now verbally, let's recall reduced row echelon form. There are 3 things that we need. First, if a row has a non-zero entry and we read left to right, then the first non-zero entry is a 1. Actually, that is satisfied by all of these, okay, but not all are in reduced row echelon form. So then there's 2 more things we need. The second is if a column has leading one, then all of the other entries in the column are 0. And this is what we see here, right? And these 3 columns that have leading ones, all the other entries are 0. And the final thing that we need is if a row has a leading one, for example, this row does, all other rows above have a leading one and to the left. So you notice this is what makes the staircase pattern. Each row above has a leading one and to the left. A is in reduced row echelon form. Now, B is not in reduced row echelon form. We do see ones sort of leading off each row, but you notice here, this column, well, if you take this as your leading one for the row, it is not the case that all the other entries in the column are 0. So B is not. Okay, we have justified verbally. Now C is reduced row echelon form. In fact, I will highlight the leading one. There's just one of them. D is not. We do have sort of ones as our first entries we see in each row if we have a non-zero entry in the row. But you see, if you take, for instance, this leading one, the row above it does not have a leading one, and that fails property 3. It's also the case that in this column, if this is your leading one, not all the other entries are 0. So D is not reduced row echelon form. E, well, this is just the 0 matrix, 2 by 2 0 matrix, and that is in reduced row echelon form. We just don't have any leading ones. So 3 of them we can do quickly for the rank. The rank of A is 3, number of leading ones. The rank of C is 1, number of leading ones. And the rank of E is 0. We don't have any leading ones, as I said, but it's in reduced row echelon form. The rank is 0. Now the other 2, B and D, you have to think about what is the reduced row echelon form in order to really answer this question. But it's not that hard in either one to see. So maybe I will make that as a comment. The reduced row echelon form of B, well, you can see what you would do. You can take, I'll say it verbally, you can take minus row 1, add it to row 4. You can take minus row 2, add it to row 3. And we would see this as the reduced row echelon form. And so the rank of B is 2. Finally, similarly for D, we can also quickly see what the reduced row echelon form of D is. D is 4 by 3. It's pretty clear to see that the reduced row echelon form of D is this. You can get there with 2 row operations. And so the rank of D, well, it's 2, the number of leading ones in this gray matrix, reduced row echelon form of D. Now we have one more, and it's a true or false. Every 4 by 4 upper triangular matrix is in row echelon form. The answer is false. So let's write it and then justify. It's always important when we are answering true false questions to understand why we are answering. Well, for here, I could just give an example. Let's give an example, and this will justify. Give an example of a 4 by 4 matrix. I need to make sure it's upper triangular, but it should not be in row echelon form. So here's what I'll start with to guarantee I am not in row echelon form. I will just put a row of zeros at the top. And now, no matter what I do after this matrix will not be in row echelon form. But I also need this upper triangular. And so let's fill in where I must have zeros. I must have zeros here. Note that no matter what I fill in here, provided I fill in at least one non-zero entry, my matrix will be 4 by 4. My matrix will be upper triangular, but it will not be in row echelon form. I don't want to put all zeros for the same reason that the matrix the 2x2 matrix of all zeros above was row echelon form. That would be the only time I would have a problem. So let's put something on 0. Here's a 5. And well, now I can do just about anything. 1, 0, 0, say 2, 1. There you go. There's an example, but there are many others, as I just was discussing. So this is the end of the extra practice worksheet number 1. Thank you.